Good evening, students. Let's carry on with our trigonometrical identity questions. The next question, tan A by secant A minus 1 plus tan A by secant A plus 1 is 2 cosecant A. Left hand side, let's move on left hand side. Take the LCM, sec A minus 1 into sec A plus 1. Here this is going to become tan A secant A plus 1 plus tan A secant A minus 1. Open up the brackets, I get tan A secant A plus tan A plus tan A secant A minus tan A whole divided by secant A minus 1 secant A plus 1 secant square A minus 1. A minus B into A plus B is A square minus B square. Now here plus tan A minus tan A gets cancelled, then I get here 2 tan A secant A by tan square A. Why? We know that 1 plus tan square theta is secant square theta. Therefore, secant square theta minus 1 is tan square theta. So it's here. So 1 tan A here and 1 tan A gets cancelled here. So what I get here is 2 secant A by tan A, and that is equals to 2 into 1 by cos A into sin A by cos A. Cos A goes up here. Here it is sin A. So this gets cancelled. I get 2 by sin A, which is equals to 2 cosecant A, which is your RHS, right hand side. It's proved. The next question, cot A minus 1 by 2 minus secant square A is equal to cot A by 1 plus tan A. I said when we always try to solve the identities, we always look at the right hand side and then we try to change the left hand side. Now we see here the right hand side there is tan, and here in the left hand side there is secant square. So can we change secant square into terms of tan? Yes. So let us do that. Cot A minus 1, 2 minus, change secant square A in terms of tan. So this becomes, we know that 1 plus tan square theta is secant square theta. So secant square A can be written as 1 plus tan square A. Clear? Then again cot A minus 1, open up the brackets, 2 minus 1 is 1 and minus tan square A. Clear? Next, cot A minus 1. Now this can be written as 1 plus tan A into 1 minus tan A. A square minus B square can be written as A plus B into A minus B. Is it clear? Why did I do this? Because I have got 1 plus tan A in the right hand side. I also got 1 plus tan A here. Now I have to change this into cot because I want to remove this. So what is here? Cot A minus 1, 1 plus tan A. Now change this 1 minus 1 by cot A, which is equals to cot A minus 1, 1 plus tan A into, I take the LCM here as cot A, and what I get here is cot A minus 1. So this becomes cot A minus 1 by 1 plus tan A. This cot A will go up, this cot A will go up, and here it will be again cot A minus 1. This gets cancelled. So what I got here is cot A by 1 plus tan A, and that is equals to your right hand side. Proved. The next question, cos theta by 1 minus tan theta minus sin square theta by cos theta minus sin theta is cos theta plus sin theta. Again, looking at the right hand side, we got to change, do the modifications or change the left hand side. I got cos and sin in the right hand side, so I have to change this tan in terms of sin and cos. So your left hand side becomes cos theta by 1 minus tan theta can be written as sin theta by cos theta minus sin square theta by cos theta minus sin theta. Then here cos theta, I take the LCM as cos theta, I get 1 minus sin theta minus sin square theta by cos theta minus sin theta. Here this cos theta will go up here, this will be cos theta minus sin theta. This cos theta will go up here and it will become cos square theta by cos theta minus sin theta minus sin square theta cos theta minus sin theta. Clear? Now the LCM cos theta minus sin theta, and here it is cos square theta minus sin square theta. This becomes a square minus b square. That means I get here cos theta plus sin theta into cos theta minus sin theta by cos theta minus sin theta. Here cos theta minus sin theta. This gets cancelled out here. So what is left with cos theta plus sin theta, which is equals to your RHS, hence proved. The next question, whole root 1 minus cos A by 1 plus cos A is equals to sin A by 1 plus cos A. Left hand side, can I write this as root 1 minus cos A by root 1 plus cos A? Yes, I can write this way. Now I am seeing on my right hand side it is 1 plus cos A, but on my left hand side it is root under root 1 plus cos A. So if I can square this, or if I multiply and divide both by 1 plus cos A by root 1 plus cos A, then this will give my 1 plus cos A. Yes. So what is the important step? Multiply and divide by under root 1 plus cos A by 1 plus cos A. So the numerator becomes under root 1 minus cos A into 1 plus cos A. Here root 1 plus cos A into root 1 plus cos A becomes 1 plus cos A. Here this becomes under root A minus B into A plus B is 1 minus cos square A by 1 plus cos A. Now 1 minus cos square A is equal to root sin square A by 1 plus cos A, which is equals to root and the square gets cancelled, which is equals to sin A by 1 plus cos A, and that is equals to your RHS. Clear? Proved? Okay. The next question, sin theta into tan theta 1 by 1 minus cos theta is 1 plus sec theta. So left hand side as it is, we write sin theta into tan theta by 1 minus cos theta, as there is no denominator here, so we have to multiply and divide the number with 1 plus cos theta by 1 plus cos theta, so that this becomes sin square theta, and which gets cancelled out from here. Let's do it. Sin theta, tan theta can be written as sin theta by cos theta into 1 plus cos theta by a minus b into a plus b is 1 minus cos square theta, which is equals to sin square theta by cos theta, sin theta into sin theta, sin square theta by cos theta into 1 plus cos theta by 1 minus cos square theta is sin square theta. This gets cancelled out, so I get 1 plus cos theta by cos theta, which can be written as 1 by cos theta plus cos theta by cos theta, which is equals to sec theta. 1 by cos theta is sec theta plus 1. Therefore, 1 plus sec theta, which is equals to your RHS, proved. The next question. 1 minus cos A by 1 plus cos A is cosecant A minus cot A whole square. Left hand side. 1 minus cos A by 1 plus cos A multiplied and divided by 1 minus cos A. Multiplied and divided by 1 minus cos A. Why? Because 1 A plus B into A minus B, this is 1 minus cos square A, I will get as sin square A. So this is the reason I am taking it here. So what this becomes? 1 minus cos A whole square by sin square A. Can this be written as 1 minus cos A by sin A whole square? Can I bring the square inside this total bracket? Yes, I can do this, and this can be written as 1 by sin A minus cos A by sin A whole square. So 1 by sin A is cosecant A minus cos A by sin A is cot A whole square. This is equals to your RHS, proved. The next question. Secant 4 theta minus tan 4 theta is 1 plus 2 tan square theta. Left hand side. Can this be written as secant square theta whole square minus tan square theta whole square? Then a square minus b square. What is a square minus b square? A square minus b square is secant square theta plus tan square theta. A plus b into secant square theta minus tan square theta. A minus b. A plus b into a minus b. Is it clear? Now, we know 1 plus tan square theta is secant square theta. Therefore, secant square theta minus tan square theta is 1. So this becomes secant square theta plus tan square theta, and this is 1. Secant square theta minus tan square theta is 1. Now my right hand side, I see there is only tan square, but here I see secant square. So change secant square into tan square. How can I write? Secant square is 1 plus tan square theta. So secant square theta is 1 plus tan square theta plus tan square theta. So which is equals to 1 plus 2 tan square theta is equals to right hand side, proved. The next question. Sin 6 theta plus cos 6 theta is 1 minus 3 sin square theta cos square theta. Left hand side. Sin 6 theta can be written as sin square theta whole cube plus cos square theta whole cube. Can I write this? Cube. Now again we know a formula. A plus b whole cube is a cube plus b cube plus 3ab bracket a plus b. Yes, we know this cubic formula. A plus b whole cube is a cube plus b cube plus 3ab bracket a plus b. Here we take a as sine square theta and b as cos square theta. Therefore, if we can write here as sine square theta plus cos square theta whole cube can be written as sine square theta whole cube plus cos square theta whole cube plus 3a. A is sine square theta cos square theta into a plus b is sine square theta plus cos square theta. Correct? But we know sine square theta plus cos square theta is 1. So it's 1 cube. This is equals to sine 6 theta plus cos 6 theta plus 3 sine square theta cos square theta, and again this is 1. Therefore 1 minus 3 sine square theta cos square theta is equals to sine 6 theta plus cos 6 theta. This is what we have to prove. We have to know the cubic formula. A plus b whole cube is a cube plus b cube plus 3ab a plus b, where we have taken a as sine square theta and b as cos square theta. The next question, sine a plus cosecant a whole square plus cos a plus secant a whole square is equal to tan square a plus cot square a plus 7. Left hand side, open up the brackets. What I get, a plus b whole square is sine square a plus cosecant square a plus 2 sine a cosecant a bracket. Again open up this, cos square a plus secant square a plus 2 secant a cos a, sine square a plus cosecant square a cos square a plus cosecant square a plus 2 sine a cos a. This can be written as 2 sine a into 1 by sine a plus secant square a plus 2 1 by cos a into cos a. This sine square a and this cos square a becomes 1 plus cosecant square a plus this gets cancelled. Here it is 2 plus secant square a plus this cos a comes here 2. So how much did I get? 2 plus 5 plus my right hand side is tan square and cot square, but here I have cosecant square and secant square. Change cosecant square to tan square. We know 1 plus tan square theta is secant square theta and 1 plus cot square theta is cosecant square theta. Therefore, cosecant square theta can be written as 1 plus tan square theta plus secant square theta can be written as 1 plus cosecant can be written as 1 plus cot square theta, and tan secant square can be written as 1 plus tan square a. So here it is 5 plus 1 6 7 plus tan square a plus cot square a, which is equals to your right hand side. Proved. The next question, secant to the power 6a minus tan 6a is 1 plus 3 tan square a plus 3 tan 4a. Here left hand side, this can be written as secant square a whole cube minus tan square a whole cube. Now we again know a minus b whole cube is a cube minus b cube minus 3ab a minus b, where a I am taking as secant square a and b I am taking as tan square a. Clear? I should know this formula. A minus b whole cube is a cube minus b cube minus 3ab a minus b, where a is secant square a and b is tan square a. So let me put up here. So a secant square a minus tan square a whole cube is equals to secant square a whole cube minus tan square a whole cube minus 3 secant square a tan square a into secant square a minus tan square a. This is 1 because we know 1 plus tan square theta is equals to secant square theta. Therefore, secant square theta minus tan square theta is 1. So this becomes 1 cube is equals to secant 6a minus tan 6a minus 3 secant square a tan square a, and this again becomes 1. Therefore, secant 6a minus tan 6a is equals to 1 plus 3 secant square a tan square a. Now my right hand side I am seeing there is only tan, there is no secant. So convert the secant into 1 plus tan square a into tan square a. So how much is this? 1 plus 3 tan square a into 1 plus tan square a is 3 into tan square is 3 tan square a into this. Open up the bracket. What I get? 1 plus 3 tan square a plus 3 tan 4a, and this is equals to RHS proved. We'll do more numericals in my next video. Today what I have done, you try to do it at your home, do it in your exercise. If you have any doubts, please give your comments in the comment box. I will reply you back. Thank you.